and in today's video, we are gonna go over the Transformers Revolution. What the what is, did Jerry, if you don't know, Jerry's my editor. He's my everything. He's basically my whole team. But Jerry, what, the transform, what, I don't go, I'm not involved in making these slideshows. That's all him. And I just like make a video on it, but like, what? Deep dive into the architecture and self-attention mechanism that redefine intelligence? What the? I'll just go on with whatever he says. Okay, so we have the path to attention from sequential bottlenecks to parallel intelligence. So the sequential problem is that the RNN bottleneck and the LSTMs process data word by word, and this sequential nature makes training slow and leads to vanishing gradients, where the models forget early context in long sentences. Oh, it's talking about AI. Oh, that's so true. Whenever I use ChatGPT, oh my god. And there's also fixed context vectors, where traditional SEQ2 CSQ models try to compress entire paragraphs into a single fixed length vector, and this information bottleneck prevented models from capturing nuanced, long, rare dependencies. Sorry. And then attention is all you need. This was proposed by a researcher in 2017 that said the transformer replaced recurrence with self-attention, and this enabled massive parallelism across GPU clusters. Oh, this is like APCSA. Instant capture of long-range, no, APCSP. APCSA is really just coding Java. And context-aware embedding, and it is the general purpose computer of the AI era. You can like zoom into this and like, this is good for APCSP and APCSA. Next, we can talk about the core mechanism of an in-depth look of a self-attention engine. So when we talk about the mathematics of attention, there's something called the scale dot product attention, and the engine computes similarities between words to assign important weights. And when you think of words, you don't really think of mathematical, but that's how like a lot of AIs works. They don't just look at the words, they like use a lot of tokens and stuff. And here's a mathematical representation of it. Of attention QKV is equal to softmax in this. This is a lot of variables to look at. But yeah, we're gonna move on to the QKV analogy. So the query is the search term, and it is what is the current token looking for, and this represents the features I need to understand myself better. Huh? I don't know, bro. This key, which is the index tag, and this is like information, and like, no, it's like what information do I contain, and it helps other tokens decide how much they should pay attention to me. And then the value, which is the payload, and it is what is the actual information I offer, and the weighted sum of these values creates the new context-aware vector. Next, we can talk about multi-head attention, where it's asking why have one attention eye when you get so many, like here. You see all the multiple arrows pathways, and this like multi-head attention allows the model to focus on different aspects. Like the first one can focus on syntax versus grammar, the second can focus on semantics, meaning, and the third one can focus on conference and pronoun links. And this is a result of concatenated and linear transformed into a rich multi-dimensional representation. But there's also something called the scaling paradox. And this model parameter rows, an emergent capability appears, which allows for reasoning and zero-shot learning. As you can see here, here's all the different GPT models that OpenAI has created, or recently. Well, this is 3 years old, but as you can see, it went from 17 million to over 1.8 trillion in just 5 years. And that's the scaling paradox. Like it gets exponentially better. You can see here, Google releases the attention is all you need paper in 2017, and then that's when GPT-1 is launched in 2018. And then only 2 years after with GPT-3, it demonstrates massive scaling potential. And then in 2022, it brings transformers to the mainstream. And this is like the 2 years progressions of each and a visualization of how like AI is changing in the world. This is interesting. I don't know what this is. I'm not gonna lie. Should we? Should I call Jerry? No, I called Jerry way too many times. Let's. Who else is on my team? Huh. Think about who I hired. Like I'm the CEO of this LLC. So like, huh? Who else did I hire? Yo, I think I fired everyone. So I guess Jerry's the only one I got. But here it's talking about the beyond natural language, which is the multimodal feature, which transforms abilities to relate elements in a sequence isn't limited to words, and it now powers AlphaFold, which predicts 3D protein structures, which is in biology. There's also VIT, which are vision transformers for image recognition. There's also GitHub Copilot, which is real-time code generation. And everything is a sequence, and therefore everything can be modeled by a transformer. Alright, so I know this video wasn't that interesting. I mean, the biology part is interesting to me, but yeah. If you have any questions, just leave it in the comments. I don't know if I'm gonna answer because I don't know much, but Jerry will actually answer for you. He knows a lot more than I do. He has a PhD in everything. So yeah, he took like 20 majors in college. I am not making this up. He is he's like the lowest. He's like a no, it's like an internship. Like that's the highest position I offered him. So yeah. Here's some of the image sources. He's an internship because he doesn't know how to fix the images, but I hope you have a good day, and I will see you in another video. Bye.